We're going to work a 7-step problem. So if you want to have paper available so you can work it with me, that would be a great idea. So I'm going to start setting up my computer to do this. If you have a question, you can still ask that. So I'm going to need, I got too many extra windows. I'm going to need Desmos calculator. All right. Okay, so here's what we're going to do. We are going to work a problem basically based on conservation of energy. So we're going to take an iPhone and put it in a Jolly Rancher. We're going to take Jolly Rancher, melt it down, and drop it from a drone from 25 meters. And this phone and Jolly Rancher has a mass of 0.135 kilograms. I want to know what is the velocity of the phone Jolly Rancher just before it hits the ground. So this 7-step problem challenges you in a new way. You will need to understand 2 equations and 2 important concepts or you won't be able to get it, okay? So this is probably the most complicated 7-step problem we're going to do in class. That's the good news. But it is more complicated than what we've been doing. All right. But it actually makes much more complicated problems simpler. We just haven't done those more complicated problems. All right, so here we go. We have a Jolly Rancher that's been melted down, a bunch of Jolly Ranchers, and we've put a phone inside the case of Jolly Rancher, and we're going to drop this from a height of 25 meters. The mass of this is 0.135 kilograms. Now, as soon as I do that, I notice we're falling, so I know that G must be a factor, even though it was never mentioned in the problem. Let's see, what else? Whoa, just before it hits the ground, I want to know what the velocity is. Okay, now, just by looking at this picture, I'm already starting to put some pieces together. I see M, G, and H. Well, MGH, well, that's U, that's potential energy. So I could go, well, I probably know what U is up here. But guess what U is going to equal? U is going to equal the K down here. Okay, and I'm figuring that out because I know my principles of potential energy and kinetic energy. And now I'm going to go and make my given unknown equation chart. Here we go. So givens, I've got M equal 0.135. And anytime I do a decimal, I usually put a 0 in front because sometimes when I'm writing in pencil, I don't see my decimals. But it's weird to have a 0 in front. So that usually tells me, oh yeah, you put a decimal there. You just didn't do it dark enough. Okay. H equals 25 meters. G equals negative 9.8. Trying to write slowly so my writing is at least somewhat readable. Good luck with that, right? Okay, so given unknown, I actually have one important unknown. That's our end answer we're looking for. But I also probably need to find U. Because if I find U, I can probably find K. So equation. Using our understanding of conservation of energy, U plus K equals the total energy. But at the very top, the Jolly Rancher isn't moving yet. So at the very top, U is equal to some number plus a K of 0 equals the total energy. So guess what? The total energy equals U. But then at the bottom down here, we're on the ground, so U is 0, and we've got K. So in that case, K equals the total, but if 1 equals 1 and 1 equals the other, guess what? Let's not even use that equation. U equals K. U at the top equals K at the bottom. And that all comes from this equation, which should have been in your video notes. So I'm going to actually erase this because I don't have room. If you have room, you would keep working, okay? So U equals K. That is a U. And U equals MGH. K equals 1/2 mv squared. Now, from here, there are two ways to work this problem. I'm going to work it probably the simpler but slightly longer way. But you could actually literally take this and substitute it in. Take this equation and substitute it in. And write MGH equals 1/2 mv squared. And then plug in all your numbers and solve for V. But what I'm going to do is I'm just going to solve for U. And then U equals K. And I'm going to do the second equation. And I'm going to do each equation separately. So we're going to substitute for U. Now, because that's just how I work and it keeps me focused, is I actually rewrite the equation. Yeah, I wrote it. Write it again. It's okay. U. I don't know what U is. That's what I'm looking for. M is 0.135. G is negative 9.8. And we are actually traveling this distance in a downward direction. So our distance is actually going to be a negative 25. Since I've discovered that, I'm going to change my table up here. That's negative 25. And that'll be a negative 25 because of the direction of our motion. So U is going to be a positive number. And now I just plug it in my calculator. So 0.135 times negative 9.8 times 25, and you should get, what is it? Let's go to Desmos. Oh, too many windows. Let's close that. Now I can get to it. So 25 times 9.8 times 0.135. Enter, and that equals 33.075. 33.075 joules. That is equal to U. But U is equal to K, so that is also equal to K, which means if K equals 1/2 mv squared, then I've got 33.075 equals 1/2 times half times a mass of 0.135 times V squared. Okay, now you should keep working underneath if you are working this. I'm going to come up here so I don't delete what I've written already, but also so you can continue to see me working. So 33.075 equals 1/2 of 0.135, if you put it in your calculator, is 0.0675 times V squared too many windows. You don't see them, but I've got all kinds of windows open. All right, so here we go. Now I can do my algebra. I'm going to divide both sides by 0.0675. And 0.0675 divided by 0.0675 equals 1. And 1 times v squared is just v squared, which equals whatever this is, which I believe is 489 point something. Let me jump over to my calculator. So 33.075 divided by 0.0675. No, 490. I don't know why I got 489 earlier today, but 490. Okay, and now I'm going to square root both sides. So go back to my calculator and hit the square root button of 490. And I should get something that my calculator is not giving me. Let's see, that's why. So square root 490, enter 22.135. So V equals 22.14. Notice I rounded to 2 decimal places, meters per second. And now we know how fast this Jolly Rancher / phone is traveling just before it hits the ground, which is pretty fast. Okay, so that is a conservation of energy problem where we're taking all of our principles that we've learned about potential and kinetic energy, and we're able to actually set those equations equal to each other, solve for one equation, and then plug it into the other equation, and then work out to get the second answer. So you have to be really careful when you see these types of problems, because they will give you all the givens look like potential energy, but they're asking for an answer that only can come from kinetic energy. And that causes lots of confusion, okay? So you have to realize that potential energy and kinetic energy, as long as we're talking about the maximum potential, maximum kinetic energy, are equal to each other. So yes, so this is exactly how you should do last night's homework. So if you were confused or lost, this will help you, I think, greatly. All righty, so I know how difficult and how not exciting doing all this math is. So what do you say we actually go and watch this Jolly Rancher actually fall from 25 meters and see if the phone survives? Shall we take a look and see what's going to happen here? Whether you wanted to or not, we're going to. So, will it survive or will it not survive? In the Pear Deck, tell me, will it survive? Yes, no, it can't survive. That's going too fast. It's going to shatter into 1,000 pieces, or the Jolly Rancher is going to protect it. What do you think? Will the Jolly Rancher actually survive? The joys of physics, getting to actually smash things. All caps, yes. Okay, no imposters. Okay, what do we think is going to happen here? If you get it wrong, we may have to vote you off. Okay, so ready? Here we are. We're gonna go ahead and watch this. Just so you know, I've actually sped up the playback speed. There's some slow-mo stuff, which is actually really, really cool at a slightly slower speed. But here we go. He's going to take all these Jolly Ranchers and he's going to melt them down. And then he's actually, let's see, he puts the phone in the Jolly Rancher and then pours more melted Jolly Rancher on top of the phone. Okay. Then he has his little advertisement. But here is the Jolly Rancher with the phone inside. And now we're going to take it up in this drone and we're going to drop it. So here we go.
Thumbs up. Best
case ever. Did that do what you expected it to do? That is pretty crazy. Little physics at work. Okay. So we could talk about how why did the phone survive, and that has to do with a transfer of energy. Notice that the Jolly Rancher was all melted and stuck to the pavement. That's probably because when it hit, it turned all that energy into heat and caused the Jolly Rancher to melt and stick to the ground, which actually absorbed some of the impact. So pretty crazy physics right there. All right, we're not going to have a lot of time to actually talk about this, but in Canvas today, your goal is to work through a skate park simulation. So it is not an Explorer Learning. I explain it in the weekly overview video, so you can look there for more details. But it's pretty cool. It's pretty simple. All the directions are in the document. So, and I think it should be pretty straightforward what you need to do. Yeah, so last thing for today, grades. Grades are in Canvas and only in Canvas, so make sure that you are checking your grades. If you are behind, make sure you're making a plan to catch up. Next week is going to be a weird week. We'll talk about it more on Thursday. Please make sure you're coming to tutorial time because I know that I haven't had time to address everything. And then in Pear Deck, you can tell me what is the most challenging part of 7 steps for you. And you have now turned the Pear Deck into student paced. And now you can use the remaining like 2 minutes to ask me questions or get started working on the skate park physics if you have not done so already. Okay, progress reports are next Friday.